Bismillahirrahmanirrahim. My dear students, Assalamu alaikum. You are watching Math with Yasir Arfan. We have a third lecture on general exponential function, how we have to find out the derivative of general exponential function. We have explained in my first two lectures what is the general exponential function, and we have a third lecture. Today we are going to find out the derivative of general exponential function. We have discussed that we have to use a very important strategy there to find out the derivative of general exponential function. We have to take out ln on both sides. So here taking ln on both sides, ln on both sides. So this is ln on both sides. So we have a property of ln that the power of the function become the coefficient of the function of ln x. So that is cos x sin x become the coefficient of ln. This power become the coefficient of ln. This is the property of ln. Now we have to find out the derivative of this one. Differentiate with respect to x. So we have to apply the operator d upon dx on both sides. That is now we have to find out the derivative here. So the derivative of ln y, we have a formula derivative of ln x, that is equals to 1 over x. So this is ln y. So the derivative of y will be 1 upon y. And then we have to find out the derivative of y. So here we have two functions. One is cos plus sin x and the another one is ln of tangent inverse x. So here we have to apply the product rule. The product rule is u as it is derivative of v plus v as it is derivative of u. So here we have to apply the product rule. U as it is, that is cos x plus sin x. So the derivative of ln tangent inverse x, v as it is, derivative of u, that is cos x plus sin x. So here the derivative of y is dy upon dx. So this is 1 upon y dy upon dx. Cos x plus sin x, it is before the operator, remain as it is. We have to find out the derivative of ln tangent inverse x. So the derivative of ln, that is 1 upon x. So here 1 upon tangent inverse x. And then we have to find out the derivative of tangent inverse x. The derivative of ln is 1 upon tangent inverse x, and then we have to find out the derivative of tangent inverse x. So this is as it is. Now here the derivative of cos x is minus sin x. We have the formula. The derivative of cos x is minus sin x, and the derivative of sine x, it is cos x. We have the formula. The derivative of cos x is minus sine x, and the derivative of sine x is cos x. So here dy over dx, so this is cos x plus sine x, this is divided by tangent inverse x. Now the derivative of tangent inverse x is 1 over 1 plus x square. X is the angle of the function. So whatever the angle is given to you, 1 upon 1 plus x square, and then we have to find out the derivative of angle here. So this is the tangent inverse x. So its derivative is 1 plus x square. And the derivative of x, it is 1, so there is no need to find out the derivative there. So this is cos x, change their positions, and we have to shift this y to the right hand side. So here derivative of tangent inverse is 1 upon 1 plus x square. So we have the formula here. So just we have to put the value there. Dy upon dx, this is cos x plus sin x into 1 plus x square tangent inverse, and this is plus ln tangent inverse x into cos x minus sin x. We have to put the value here. We have to put the value here, the value of y, that is tangent inverse with the power cos x sin x, cos x plus sin x. So this is the formula of this general exponential function here. So this is the answer of this question. Dear students, it was the third lecture on general exponential function. Thank you so much, boys. If you like this video, please share it and subscribe my channel Math with Yasser Arfat. Allah Hafiz.